All right, so I'm going to do two more proofs. I got really lucky here because this is a cool looking proof. All right, I don't lie about much when it comes to proofs. So I'm a pretty straight shooter. So in this proof, we need to prove that triangle BEC, that's this triangle right here, is congruent to DEA, that's this triangle here. Okay, so what are we given? Well, we're given a pair of congruent sides, BC and AD. We're also given the fact that they're parallel, right? So because we're given both, that's what I can say both, okay? So I right now have a pair of sides that are congruent. So now, if I take this parallel line and take this parallel line, okay, I can use one of the diagonals, and we haven't really talked about diagonals, but AC is the diagonal. I can use this diagonal, and I've created a Z. And now, if you see the Z, you have alternate interior angles. Remember that parallel lines lead to congruent angles. And when you see this Z, right, I'm sorry, the Z, that's how you do it. You have in here alternate interior angles that are going to be congruent. I can't spell. Alternate interior angles that are congruent. Okay, so these two angles will be congruent, and that'll be a pair of angles. And then you could also do it this way too. And you'd have these two angles congruent, but I'm not going to, okay? I'm going to go back to blue. I'm going to use this pair of angles here and here. Those angles formed at that point E are vertical angles. And again, just to kind of show you some differences, I'm going to use vertical angles. So my triangles will be congruent by AAS. Notice the S is not in between the A's. AAS. If you were to use both pairs of alternate interiors, you would be ASA. So notice that this proof can be done a couple ways. That's the beauty of mathematics and the difficulty of mathematics. It can be done many ways. Okay, just have to be open-minded. All right, so let's take all this away and let's talk about how we're going to do this proof. All right, so because of the parallel lines, again, I'm going to use AC as my transversal. I'm going to say that this angle here, BCE, this angle here, is congruent to this angle here, DAE. And that's because parallel lines and alternate interior angles. Parallel lines, there we go. Good, I got it. Now I'm going to use this vertical angle pair, again, congruent angles, AED and BEC. AED, BEC, and again, that's because they're vertical angles and they are congruent. There's another pair. And now, again, if you're still at all confused, my two triangles will be congruent. I have an angle pair, I have a side pair, I have an angle pair, but again, it's angle, angle, side. This would have to be the side for it to be angle, side, angle, and it's not. So it's not angle, side, angle, it's angle, angle, side. So I now know that my triangles, and those triangles were supposed to be BEC and DEA. They are going to be congruent. And that is by angle, angle, side. Small green check mark. I'm gluttonous for the big green check mark. Got it. All right, one more proof coming. Okay, here's the last one I'll do. I'm doing this not because of the geometry involved, but just because the difficulty of the picture. All right, so if you look at this, you're trying to prove that triangle ABE is congruent to ACD. So this is hard because we call these overlapping. So I would actually suggest that you take this and draw these two triangles over to the side. So A, B, E, A, B, E, and then what? A, C, D. A, C, D. Only because this overlapping is tough to see, you know, all that fun stuff. So I know that AD is congruent to AE. So AD is here, AE is here. So there's a pair of sides. I also know that angle B is congruent to angle C. There's a pair of angles. Let me do that I'll do this in red. Right, so sides, there's your pair of sides. Angles, angles, there's your pair of angles. Okay, so the question is, where is the other piece going to come from? Because they really don't have anything in common. Well, you have to kind of look at the overlap on the figure. So watch this. I'm going to use two different colors. I'll use green and orange. So here is ABE. And orange. And here is ACD. Now, I know there are some spots where they overlap, right? They touch, right? But the question is any part, side or angle, totally in both triangles? Now, if you look at these sides, sure, there's some overlap right here, but the green keeps going and the orange stops. Same thing here, right? And yes, of course, there's some overlap here. But let's draw your attention right to here. Do you see how angle A is in both green and orange? This angle is going to be congruent to itself. This is another way to use the reflexive property, but for angles. This angle A is going to be your second angle in these two triangles. And you're going to have angle, angle, side as your way to prove them congruent. So again, this is like a visualization nightmare for some people. I get it. So just do your best, right? Do your best. So I'm going to erase this. So all I have to say is that angle A is congruent to itself. And I can use just one letter because it's all up there by itself. That's the reflexive property. And let's go ahead and mark the triangle. So if I focus on, sorry, let me get my bearings back. Oh, there we go. If I focus on, sorry. Let's focus on triangle ABE, right? ABE. Again, I have this side AE and ABE. I have this angle and I have this angle. And again, it would have to be this side in blue for it to be angle, side, angle. It's not. It's angle, angle, side. Angle, angle, side. So I just have to say my two triangles. Triangle ABE and triangle ACD are congruent by angle, angle, side. Green check mark. So not a lot of work, but again, it's the visualization that was the tough part of this one. Okay, cool. So again, we're talking about, let's make a list real fast. Again, we're talking about bisecting. We're talking about midpoints. We're talking about parallel lines, perpendicular lines, right? All kinds of fun stuff in these vertical angles, right angles, okay? And of course, side, 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 angle, side, angle, side, angle, 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 side, and HL. So have fun. Hopefully you get better as time goes on, and don't struggle too much. Get some help. I can help you create a mindset to get through these proofs. All right, thanks for watching.